Hello, this is Mrs. Taylor, and I'm going to walk you through how to factor a quadratic trinomial using the box method when a does not equal 1. So just a reminder that we have the standard form of a quadratic, which is ax squared plus bx plus c. And when a equals 1, there's no number that appears to be here. But we are going to look at a different situation. We're going to look at when a does not equal 1. So, for example, in this problem, in front of the squared term there's a 10. So this would be an example of when a does not equal 1 because it equals 10. And the result of that is that sometimes finding your filled in boxes can be a little challenging depending on which number you're factoring, but for the most part it's not overly difficult. It's just a little extra work. So to start with, we need a box, and we're going to have a 2 by 2 because when we factor quadratic trinomials, we know that we get binomials. That means 2 terms. And so I have 2 terms here and 2 terms here. And when we use the box method, we start from the inside and work out when we're factoring. And I know that my squared term, this 10f squared, will go in the first box, so top left box. And my constant term, the 3, will go in the bottom right box. And what I have to do, as seen in the previous movie, our video, is these 2 boxes have to fall under 2 conditions. They have to have a product, a specific product, and a specific sum. The product would have to be the same as the product that I would get if I multiplied diagonally in the opposite direction. So whatever terms fill in these 2 empty boxes, when I multiply them, I should get the same product as when multiplying 10f squared times 3. And 10f squared times 3 would be 30f squared. And the sum of these 2 boxes, so the same 2 empty boxes, whatever terms fill those boxes, have to add to the middle term of my trinomial, so up here, 17f. And so there are an infinite number of numbers that add to 17. But there's only a select number that multiply to 30. So where we start is we usually list the factors of 30. And we don't really stress about the f's because we know that each of these boxes will have an f. And that will take care of the f part, because when I add them, I'll just have an f as part of my sum. And when I multiply them, I'll have an f squared. So what I'm really looking at to figure out what terms go in these empty boxes is factors of 30 that add to 17. And so I need to list off the pairs of factors. And the thing to remember is, yes, 30 times 1 is 30, but you could also have -1 and -30. So I think a lot of students miss that detail, and so when they're trying to figure out what their factors are that sum to a negative result, they sometimes get a little confused. So don't forget that positive numbers can be factored with 2 negative numbers. Other factors of 30, we have 3 and 10, we have 15 and 2, and we have 10 and 3. And if you ever are unsure what the pair of factors are, you can always try dividing and see what the result is. So if I knew 30 was divisible by 10 because it ends in 0, and I wasn't sure what the other factor is, I could do 30 divided by 10, and the result would be the other factor, which is 3. Same thing with 15 and 2. It's 0, so I know it can be divided by 2 because that's an even number, but I maybe am not sure what the other factor is. So 30 divided by 2 is 15. Alright, I think I've got a pretty good list here. I'm looking for the two that when I add them, I get a sum of 17. And 15 and 2 definitely add to 17. So those are my two factors that I fill in the missing boxes with. So after I have my two terms filled in, I now need to look for the greatest common factor, the GCF, across the rows and the columns. Across the top row, each term has an F, so I know there's going to be GCF of F. But 10 and 15, I need to figure out their greatest common factor. And if you're a visual person like me, you may want to make a list of those factors off to the side. So 10's factors and 15's factors, just to kind of get a list that you can look at to figure that out. So the factors of 10 are 5 and 2, 10 and 1. 15's factors are 5 and 3, 15 and 1. And when I look at my list, I notice that they each have a 5 as a common factor and a 1. And even though there are two common factors, I want the greatest common factor, which would be 5. So across this top row, my GCF is 5F. I continue using that strategy, so along the bottom, 2F and 3, they don't both have an F, so F is not a greatest common factor. 2 and 3, 2 can be factored with 2 and 1, 3 can be factored with 3 and 1, so their GCF is a 1. It's the biggest number they both can be factored with. Alright, columns. So down this first column, they both have an F, so a GCF of F. 10 and 2, based on my list down here and what I did in the bottom row, they each have a common factor of 2 and 1, but I know that 2 is the greatest, so 2F. And then this column on the right, again, based on my list of factors down here for 15, they share a 3 and a 1 as a common factor. However, 3 is the greatest. And again, they don't both have an F, so that means that F is not a GCF. So that is the tool that I use to factor, but my actual factors I have to write out. That's what's along the sides here. The GCFs are the terms that I would use to create my binomials that are factors. So down here on the left I have 5F and it's a positive one, so that would be 5F plus 1. And then my factors along the top, or my terms, are 2F plus 3. And again, I've not really spoken about the equal 0 part yet because factoring is such a big process. I feel like it's easier just to do one thing at a time. Focus on factoring, and then we'll talk about solving. And the way I'm going to solve this is I'm going to use the zero product property, and it states that if one of the sets of parentheses equals 0, then the entire product would be 0 no matter what was happening in the other set of parentheses. And how I apply that to solve this is, what it means is that I just take each factor that I just found and write that it equals 0. I set it equal to 0. And when I solve those equations individually, I get solutions, because if just one set of parentheses has a value of 0, the entire product is 0. So to solve this factor on the left, I would subtract 1, and I would get 5f equals negative 1. And it's 5 times f, so the inverse would be to divide. So divide by 5. And the result is a decimal, so I'm just going to leave it as the fraction. F equals negative 1 over 5. That's perfectly fine to leave your answer that way. Over here on the right, we subtract 3 from each side because I'm adding 3, and to solve you do the opposite. So I have 2f equals negative 3. And again, it's 2 times f, so the inverse would be to divide by 2. And my result would be another fraction, so I'm going to leave it as negative 3 over 2. And so my solutions for this quadratic equation are negative 1/5 and negative 3 over 2. And that's how you would use the box method to solve a quadratic by factoring when a does not equal 1.